And you're with me, Arun Sharma. And we are doing this session, we're continuing the previous year questions in our schedules on YouTube. And welcome everyone to the class. And in today's session, just try to log in from my own. And in today's Yeah. So, in today's session, we are continuing our view or our look into past year CAT papers and past year questions. And as you know, understanding or getting control of past year questions is one of the most important aspects of your CAT prep journey, because it's only after you uh, organize your thinking on each chapter, on each topic, that you start working on your past year questions. And this is we are continuing with the quants part of that, of course. I'll take some sessions on DI also, uh, discussing past year questions. And this is the first one I want to discuss today. Uh, and before I start, as you can see, the message is loud and clear. Unacademy Plus is Unacademy Plus is one of the great ways to actually prepare for this exam. And you can take uh, a subscription to Unacademy Plus, where the subscription can be as long as 1 month, 3 months, 6 months, 12 months, etc. And if you take the CAT subscription on Academy Plus, you'll also get access to my own courses. My course, foundation course on DILR, the foundation course on data interpretation and logical reasoning. It's a new course. It's starting at the 5 p.m. slot uh, on 21st of January. And as you can see, if you use the promo code arun.yt, you will get an access to the live classes on this course, as well as the best part of Unacademy Plus is that you will get access to around 20 25 odd teachers who are continuously available on Academy Plus to solve your doubts and to actually uh, train you on various aspects of this exam. So almost everything you could hope for is covered on Academy Plus, right? So without any further ado, let's move into the first question for today. How many three-digit even numbers can you form such that if one of the digits is 5, the following digits must be 7? So we are looking at three-digit even numbers. The best thing and the most important thing to do in these kind of questions is to actually build the questions in such a form, or build your structure of thinking in such a form that you have absolute clarity. And the more clarity you have while solving these questions, the better uh, your solving becomes, the more precise your solving becomes. So we're looking at three-digit even numbers which are to be formed, but there's a condition in this uh, which is mentioned here. And that condition mentioned here, as you can see on the screen, is that if one of the digits is 5, the following digits must be 7. So please understand that this only applies if one of the digits is 5, the following digits must be 7. So obviously I cannot put this 5 and 7 in the last two digits, because then it will not remain an even number. Hence, uh, if I'm using 5, I'll have to use a number in the 570s, right? But the condition is not talking about the necessity of the use of 5. The question also says that you can, if you don't use 5, there is no constraint. So if I go to thinking about numbers in the hundreds, so from 100 to 102 to 104 to 106 to 198, the number of numbers you have here is 50. And that 50 comes from using the arithmetic progression formula of number of terms, where you use the difference between the first and last term divided by common difference plus 1. So in the first and last terms in this series, there is an arithmetic progression with common difference 2. So for the difference between the first and last terms in this series is 98. So 98 divided by 2 plus 1 gives you 50 terms. So there are 50 terms in this, but you have to remember that you actually cannot use numbers in the 150s, because you can't use the numbers 150, 152, 154, 156, or 158, because of the fact that these five numbers have a 5 in them, and if there's a 5 in the number, it has to get followed by 7. So apart from these 50 numbers, you'll have to remove those 5 numbers. So in the hundreds, what you can see is after the removal of those 5 numbers from those 50 numbers, you are left with 45 numbers overall. Now if you go to the 200s, the same story will repeat. 45 numbers again, 200, 202, 204, all the way up to 248. Then 250 to 258 will not be used. You can't use those. And from 260 to 298, you can use everything. So 45 numbers in every 100. So normally, if you go from hundreds to 900s, you will have 9 sets of 45 numbers each. Right? 9 sets of 45 numbers each. But the problem here is that the 500s have to be treated separately and differently. So the problem here is that the 500s will not give me the whole set, but in the 500s, as we saw, in the 500 I'll have to go into the 570s, and in the 570s I have only 5 numbers, 0, 2, 4, 6 and 8. So if I look through this situation, I realize that in the 500s there are 5 numbers, and the remaining 8 sets of hundreds, I have 45 numbers each. So the correct answer to this question is going to be 8 into 45 plus 5, which is 365. And that's why option C is the right answer in this question. Let's look at the next question now. And this is an interesting question. Try to look at this question. I'll first give you 2 minutes to think about this question. Try to solve this in a 2-minute time frame, and then we'll discuss this question together. Let me just realign the board. Can you see it now, Ritik? I've just expanded that a little bit. Right. So you can have a look at the options also. ये दो options तो यहाँ दिख रहे हैं. Third option मैं तुमको दिखा देता हूँ. ये थर्ड और फोर्थ ऑप्शन है. ये भी कैट का क्वेश्चन है पास्ट, और इस क्वालिटी और इस लेवल के क्वेश्चन आ रहे हैं. एंड इसमें एक अप्रोच लेना पड़ता है. यू हैव टू टेक एन अप्रोच वेर यू हैव टू थिंक अबाउट दिस क्वेश्चन इन टर्म्स ऑफ वैल्यूज. सो इसमें क्या दिया हुआ है? देर आर 50 इंटीजर्स A1 to A50, राइट? सो यू स्टार्ट ऑफ थिंकिंग अबाउट दैट कि ओके, I have 50 integers in this situation. Let's call them A1, A2 up to A50. And then the question says that in this question it says that not all of them are necessarily different. So they can be some same, and there can also be some different. So that's open now to us. And they say let the greatest of these 50 integers be referred to as G. So let's call G as the greatest. The question tells us to call G as the greatest and L as the least. The integers A1 to A24 form sequence S1. So when they tell us this, at that point we realize that the sequence S1 is the integers A1, A2, A3 up to A24, and the rest form sequence S2. So the rest means A5, A25, A26 up to A50. This forms S2. And then the question says each member of S1 is less than or equal to each member of S2. That means all these numbers have to be less than or equal to these numbers. So what you can work out is that G will have to be in this list and L will have to be in this list. So the first question says that if we change the signs of all the values in S1, so let's obey what they are telling us. If we change signs, so changing signs means you multiply each element of this by -1, and S2 would remain unchanged, so S2 is getting multiplied by into 1. Which of the following statements is true? Now when you are trying to test a statement which says which of the following statements is true, when you are trying to test something like that, your whole focus in the problem becomes that you're trying to find, you're trying to, when you look for an option, you're trying to reject that option, or you're trying to find a case where that option does not work. So even if you can find one case where that option does not work, you are going to be good enough to reject that option as a definitely true statement. Right? So in this situation, when you look at this question, every member of S1 is greater than or equal to every member of S2. You can have a very simple scenario here which you can think of, and that scenario could be something like, I just rub this off, the top part off. The scenario could be that the scenario could be that if I take 1, 2, 3 up to 24 as the integers in S1, and 25, 26 to 50 as the integers in S2, and then I multiply S1 by -1, so all these numbers become -1, -2 up to -24. And if you can see very clearly every member of S1 is greater than or equal to every member of S2. This is something which is not happening here. So option A gets rejected. Please understand, the must be true case is a very specific logical case in such situations. And what happens in the must be true case essentially is that even if you can find one situation where it is not true, such that all the other constraints are being met, then you reject that option. So if you look at this question, we have obeyed by when we assume the values 1, 2, 3, 4, 5, 6 up to 50. When we assume those values, we obeyed that every element of S1 is less than equal to every element of S2. This is constraint 1 in the problem. We obeyed that L is in S1, and we also obeyed that G is in S2. We obeyed all these three things, and we also obeyed the fact that okay, we obeyed all these three constraints. There are just three constraints in this question, right? And although the question tells us that every each member of S1 is less than or equal to each member of S2, there can be an equal to case also. But it does allow us to use less than also. So when we're not using equal to cases between numbers on this side and numbers on that side, we are not contravening any condition of the question. So while we have maintained all the constraints, on multiplying by -1, we have seen that this is not happening. Option A is not happening. And which means that we can reject option A on that basis, that I have been able to find one case where option A does not work. And likewise, option B says G is in S1. Now when I multiply these numbers, if I have assumed these numbers, 1 to 24 in S1 and 25 to 50 in S2, if I have assumed these numbers and then I multiply S1 by -1, I can see that my G still remains in S2. So if G is remaining in S2, G is in S1 is the wrong conclusion. It might happen in some cases, but definitely not here. So option B gets rejected again, right? And option C, if you look through, if all numbers originally in S1 and S2 had the same sign, now we have made sure that in this case at least they had the same sign. Then after the change in sign, the largest number of S1 and S2 will be in S1. That's not happening. The largest number of S1 and S2 is still 50. So just by assuming one set of values, you have been able to eliminate three options, and hence the correct answer in this question is going to be D. D is going to be the correct answer in this question. And that's about it. Let's look at the second question. Now in this scenario, what they're telling us is that elements of S1 are in ascending order and those of S2 are in descending order. So in this case, what's going to happen is S1 will be structured with 1, 2, 3 up to 24, moving from A1, A2. Yeah, even if you can find one case where the option is not working, then it is must be true is removed then. एक भी केस अगर मिल गया तुमको किसी भी ऐसे क्वेश्चन में, if you can find only one case where even if you can find one case where you can reject the option or reject the truth of the statement, then that statement becomes true. So let's say I'll give you a small example. Let's say if I tell you that that a batsman X scores a century every time he goes out to bat. If I make this assertion and you find one case where he went out to bat and he did not make a century, so that is enough to reject my assertion, right? My assertion may be true, but it may be true most of the times, but it is not definitely true even if you can find one case where he did not make a century. So that's something I will pass. I always pass my exams. So if you failed even once in your life, then this assertion is not true, right? It is mostly true, it is almost true, but not true, definitely. And what it says further is that elements of S2 are kept in descending order. So that means my elements of S2 I want to keep as 50, as 825, 49 as 826, all the way to 25 as A50. Then what does it say? After this it says A24 and 25 are interchanged. So if A24 and 25 are interchanged, 24 will come, 50 will come here and 24 will come there. Hi Shubham, welcome. 50 will come here and 24 will go there. Then which of the following statements is true? So if you look at the first statement, S1 continues to be in ascending order. This is correct because the 24 got replaced by a larger number and we are not affecting anything between A1 to A23. So this is perfectly correct. So S1 continues to be in ascending order is correct. S2 continues to be in descending order is wrong because S2 now you can see the first number is 24 and the next is 49. So this does not work. Anyway, you've got the answer. Option A is the answer. So you don't need to check option B and C. But C, as you can see, in C, S1 continues to be in ascending order, yes. But S2 in descending order, that's not happening. So this won't work. And none of these is also not required because statement A is correct. And hence, option A becomes the right answer. Right? Let's look further. Next question. Third question. Have a look at this one. So again, for this question also, we'll start off from an elementary understanding that okay, let my S1 be 1 to 24. And S2 be 25 to 50. The constraint of the second problem is gone now. And then it says that every element of S2, every element of S1 is made greater than or equal to every element of S2 by adding to each element of S1 an integer x. That means what is being done? Get a fix on that before you think ahead. Plus x is done on each element of S1. These are the elements of S1. And when you do a plus x on each element of S1, every element of S1 becomes larger than every element of S2 also. Or equal to or greater than every element of S1. Let's call it S1 dash. Every element is greater than or equal to S2. Now for that to happen, you realize that the question is asked about x. What is the lower limit of x? Because the question says x cannot be less than. So we're looking for the lower limit of x in this question. And if I look for the lower limit of x, given the situation, I can see that in this situation, numerically, that number should be 49, at least. In this question, that number has to be 49 at least because the 1 has to be made equal to or greater than 50. So if I replace it with the smallest value of S2, the smallest value of S2 is going to be 25. So 25 is not the lower limit of x because if I use 25, I can see that 1 plus 25 will not cross 50. And the largest value of S2 makes a little bit more sense. So if I use 1 plus 50, this is definitely going to be greater than 50. But if you look at option D here, option D को अगर देखते हो तो what you realize in option D is that they are giving us an option like G plus G minus L. तो G minus L इस केस में 50 minus 1 है. And you can verify experimentally that's 49. You can verify experimentally here. If you take x as 49 and add this to every element of S1, if you take x as 49 and add it to every element of S1, then every element of S1 will become greater than or equal to every element of S2. Right? So you will even have the limiting case where 1 plus 49 is greater than or equal to 50. Even this case gets mashed, and hence the correct answer here in this question is going to be G minus L and not the largest value of S2. So option D would be the right answer here. Right? चलो एक क्वेश्चन और देख लेते हैं before we wind up. Just a reminder, do a subscribe to Unacademy Plus. Use my promo code arun.yt to subscribe. You'll get a 10% discount on the existing fees. The question says, let D be a recurring decimal of the form D is equal to point A1, A2, A1, A2, A1, A2. So when you look at this structure of number, you realize that we are talking about a 2-digit recurring number, right? With at most one of the 2 digits being 0. So which of the following numbers necessarily produce an integers when multiplied by D? So what happens is that this kind of decimal, something like 0.23 recurring, something like 0.38 recurring, you have to know that in a question like this, decimals or any division, decimals with 2-digit recurring only happen because of the denominator 99. So that's the knowledge you need in this question. So what you need to know is that if you're looking at a ratio like 1 by 99, a fraction like 1 by 99, its value is 0.01 recurring. 2 by 99 is 0.02 recurring. 3 by 99 is 0.03 recurring, and so on. 4 by 99 will be 0.04 recurring. 0.23 recurring would be 1999, 23 by 99, and so on. So what you realize that a number of this form, which is giving me a decimal of 0.A1A2 recurring, in fraction terms, this will be something, let's call it x divided by 99, depending on the value of A1, A2. And obviously, if you multiply this fraction by 198 from amongst the options, it's pretty evident that what you will get will always be, you'll always produce an integer when you multiply this by the recurring decimal D. Hence, the correct answer will be 198 because that's the only multiple of 99 in the options. So option C is the correct answer. And I hope you enjoyed this broadcast. Please do subscribe to Unacademy Plus, and I look forward to having you. As I said at the start of the class, a new course of mine called Foundation Course on DILR is starting on 21st January on Unacademy Plus, 5 p.m. I look forward to having some of you there, and you will need to subscribe for Unacademy Plus to be able to attend that, and you can use the promo code arun.yt to do that subscription. It'll give you a 10% discount on the existing fees. Right then, so thanks a lot for attending. I hope to see some of you soon in my plus classes. I'll wind up now. Thank you so much. Thank you, Ritik. Good to hear that you could get a strong learning experience. Bye bye, bye bye, bye bye, everyone. Thank you for watching.